and they're still independent, they're just a bit confused, and this is called mild cognitive impairment, or MCI. And then there are people who have reached that clinical threshold to necessitate a diagnosis of Alzheimer's disease, hereafter AD. Now, Alzheimer's disease has a more prodromal stage, where the neuropathology of the disease can exist at low levels without the corresponding or associated cognitive deterioration. Now, people can exist for weeks, months, years permanently in this state. Some people go on to develop MCI, and some people just stay at MCI rather than developing full-blown Alzheimer's. Now, this gives us an opportunity to say, okay, if we can predict who's going to transfer from these three states to a more worse diagnosis, then we have the opportunity to implement intervention studies, or implement interventions. So you might think, okay, we can't delay dementia, but actually a recent meta-review by Lancet, the journal, which they do every year, suggests that up to 45% of Alzheimer's disease may be preventable across the lifespan. So things like having less education when you're a kid, moving towards diabetes and obesity in midlife, and then social isolation, air pollution, and that type of thing in later life. So 45%. So it's got to the point now where we know it's not inevitable. And so therefore, if we can isolate those, or identify those individuals who are at risk and implement these interventions, we may be able to prevent up to 45% of Alzheimer's disease. Now, how do we do this? So there is a concept, well, one of the ways that we do this is by reinforcing cognitive reserve. So there's a concept called cognitive reserve, and well, I like to think of it like the beams on an old cottage roof, okay? So imagine there's snow, well, you don't have to imagine, there's an AI-generated image there. So the more snow that goes on the roof, the more it's going to be under strain. Now, the more beams it has, the more snow it's going to be able to take before the roof collapses, okay? So you can think about the snow as the neuropathology of Alzheimer's disease, for example, the amyloid plaque, neurofibrillary tangles. People do display and have been shown to have that neuropathology, but don't have the corresponding cognitive deterioration, and part of that may be due to cognitive reserve. So things like socializing, things like there's evidence of Mediterranean diet, for example, things like being in an intellectually stimulating job, and so on. Now, another thing that I'm probably going to be later, but I'll try to speed up. So another potential for the application of AI prediction for Alzheimer's disease is that recently we have there has been the development of drugs which for the first time have been shown to both clear the neuropathology of the disease while also reversing the cognitive deterioration. The problem is, and one of the reasons why it's been rejected by the NHS in this country, is it's only able to work on people who are diagnosed in a super early fashion, and it only works in a very small subset of people, and apparently the side effects are particularly unpleasant. But this highlights the need for that early diagnosis, and the reason why it's so exciting is, to quote one scientist on Twitter, back when scientists were on Twitter, it shows that for the first time we have developed drugs which can hurt Alzheimer's disease, or the neuropathology, and if it bleeds, we can kill it, which I think is a quote from Predator. So, AI within healthcare applications has lagged behind other applications of AI. You know, there's AI on our phones, there's AI on our TVs, there's a whole host of things that we're using AI for. But medical applications have lagged behind. And within the domain of dementia, there are a bunch of different reasons why. Firstly, this over-reliance on unrepresentative, expensive or invasive data, bad methodologies, lack of explainability, lack of obvious usability in existing clinical practice, and limited data, and expensive in time to collect more rather. Now, over the last 5 years, myself and my lab at Goldsmiths, the Data Science and Software Computing Lab, have been aiming to address some of these needs, or some of these obstacles. So So we can talk about the first set of studies that we published, where we were trying to predict, based on classical classification models, what diagnoses a person will receive at the end of a study period, based on what diagnosis they had at the start of the study period. So you can imagine we're following these patients as participants over weeks, months, and years. At some point they come to the study centre for the first time and they have a diagnosis. And they have the data collection across the study period. And then what we say is, once they stop coming to the study and receive their final diagnosis, what can we predict what that diagnosis will be? And crucially, can we predict whether that participant has deteriorated? Okay? Does that make sense? And so therefore, what we used was a very, very widely used study called ADNI, which is 80% white and wholly US based. And so it falls into that problem of unrepresentative data, but we were able to obtain other data which is focused more on underrepresented populations in order to validate that not only were we able to predict, based on the baseline measurements, whether that person is likely to deteriorate, but we were able to validate that on non-white, non-Western data sets. We focused on methods that are less black boxy, so it's all very well and good having these deep learning fancy, LLM-based models, but when we're looking at specifically a medical domain, we need to be able to explain not just what our predictions are, but how they're obtained. So if I come to a doctor and say, that woman's going to get cancer, the doctor's going to say, how do you know? And I'm going to say, well, my model told me. It's not really acceptable. And so therefore we focused on methods which were more inclined towards that sort of being able to lift the lid on the black box. And then we set about making more common the adherence to standardized reporting methodologies in order to make the publication more transparent and more easily replicated. But there's a problem here because ultimately these studies are classification studies, right? So they treat, they're able to say whether someone is likely to develop a Alzheimer's disease, yes, no, but they don't account for the inherent temporal element of the disease. This disease progresses over weeks, months, and years, okay? And so therefore we can't account for the influence of time. Now the classical classification models do not do this, but survival-based models, in particular the Cox proportional hazard model, has this concept of hazards being moderated by time, which are then moderated by the features as time goes on. So it's time point 0, time point 1, time point 2. The features will then moderate that hazard, meaning that we end up with a timeline of risk for participants, giving clinicians and participants a lot better information and being able to model that temporal element. Now the classic Cox proportional hazard model is very good at doing this, but it doesn't scale well to high dimensional data, which is classic sort of what cohort data looks like, right? In comparison, machine learning models do scale to high dimensional data, but they're not very good, as I said, to modeling time. And so recently, what has happened is people have combined such that we have survival-based AI, so your sort of random forest, your deep learning, your neural networks, your transformers, but with the underpinning of that theoretical framework of the Cox proportional hazard model. Okay? I hope that makes sense. So our contribution to this area, first of all, we use the English longitudinal study of aging to establish for the first time, or one of the first, that the survival-based AI does indeed perform better than the standard Cox proportional hazard model. And that was something that was in dispute. My supervisor, my second supervisor out at King's, said he had a tweet that said, oh, we'll never find a study that proves that survival AI is better than Cox. And when I did, he said, I'm going to edit my tweet, and then he didn't, which was disappointing. So then we looked at validating the ELSA study on again, the admin, and then we looked at things like comparing linear versus non-linear models. Okay? So for the first time, we were able to look at things like survival around the forest, which applies its trade on data that is very much a bit more, I guess, complicated in the relationships between risk and outcome. Then we were able to look at survival neural networks, for example, survival deep hit, which produced good results, but again, we had that question of what the black box, whether it was sufficiently explainable in order to really work within a clinical setting. And then finally, we talked about survival transformers. Now, this basically says what I just said. Now, let's talk about survival transformers. So, looking at these two statements, what are they? This is a call and response moment. They're sentences, right? Of varying lengths. But what are they also? They're timelines. Okay? So the trick, which I didn't come up with, I wish I had, was to treat temporal data as if it's a sentence. So actually at time point 0, time point 1, time point 2, each of these are words in a sentence which are made up of the specific temporal time point and then a linear combination of the features at that time point. And from there, what you can do is you can modify a transformer, which is the architecture that underpins things like ChatGPT or the other ones, and therefore you can model the risk of developing dementia with a lot more depth because of this very rich and very complex transformer architecture. But again, what do we have in terms of, we have good predictability, but ultimately we don't have that explainability. Now, we talk about 60% of new dementia cases being in developing economies, which are predominantly non-white. Now, almost all of the commonly used data sets, ADNI, 80% of the studies in neuroimaging prediction studies use ADNI. The vast majority of studies use data sets that are wholly white, wholly Western based. Okay? There are recently some efforts to collect data within non-white, non-Western countries. For example, India has just started a study a few years ago called the Longitudinal Aging Study of India, which is the most pleasing acronym of LASSI, if you know your Indian roots. So there has been a focus to really prioritize collecting that type of non-white data. Unfortunately, this takes years, and so another way to approach it is to create synthetic data. Okay? So for the last two of our papers, we created variational autoencoders, which is a type of model which can generate synthetic data based on data that we originally have, a small amount of data that we have from underrepresented populations, and then immediately we could spin up, potentially infinite amounts of data, which is similar, shares the similar distributions and traits as the data set from underrepresented populations, but it is obviously a fraction of the cost to collect. Also, obviously, it makes things cheaper. Now, the most recent study, and the study I presented last week, I think, in Cyprus, was, so we talked about the fluid biomarkers which are collected via lumbar puncture. We talked about how it's not a very good time to be strapped down and drilled into your spine, collect the cerebral spinal fluid. So what people have been starting to do is move towards more blood-based biomarkers, and Bill and Melinda Gates Foundation recently launched an initiative to explore this area, right? I was part of, I think, one of the sub-studies for this, where we use the biomimesis data in order to look specifically at proteomics collected via blood tests. Okay? So instead of having that unpleasant procedure, or alternatively, instead of undergoing a PET scan, where they inject you with radioactive material and put you through a scanner, which if you're potentially confused from cognitive deterioration would be a pretty disorientating experience, I would imagine. We compared that against combining both proteomic blood-based data with neuropsychological tests in order to see whether we could predict someone's current diagnostic status in terms of CN, MCI, and AD. So we have 2 papers. One was accepted and presented last week at a conference in Cyprus. We are looking to extend this to a full journal paper, which will be submitted in the next few weeks. So we were able to demonstrate that this combination of neuropsychological tests and blood-based biomarkers was able to predict the diagnostic status of participants. So the conclusion after everything, after 5 years, is I'm very tired. But also the actual conclusion, and what you're probably here for, is that I hope I've sort of conveyed that AD is a very complicated illness. And those 3, by the way, those 3, CN, MCI, AD, those aren't set in stone at all. Like one man's mild cognitive impairment is another guy's bad day, you know? So like, these are not, although they are diagnostic criteria, they are not set in stone. I met a guy coming out of the University of Johannesburg who actually was able to identify 10 subtypes for mild cognitive impairment. Okay, so it's an extremely complicated disease, and it has a number of challenges associated with it, not just within the realm of AI prediction, but in general. But within AI prediction and clinical prediction modeling as a discipline, there are a number of obstacles which have prevented more medical AI models from being applied within healthcare domains. The last 5 tiring years, we've been attempting to address and produce papers which have addressed these areas. However, there's more to do, which means I won't be sleeping anytime soon. So yeah, that's me. Thank you for your time. Any questions? Yep.
Hey, thanks for the wonderful talk. You probably answered this already, but one question that strikes me is, are there any other correlational environmental factors that can help predict early onset of any class of dementia?
So early onset in particular has a strong genetic component. So familial Alzheimer's, which is a minority of cases of Alzheimer's, has a strong genetic component, and that one is most likely to be early onset. So sporadic Alzheimer's is the most common one, which is less of a genetic component. Although the ApoE4, which I mentioned, is a risk factor. But there are things like, for example, Shannon et al. In 2023 and others actually identified the Mediterranean diet as being a particular protective factor against Alzheimer's. When I was out in Cyprus, I spoke to one of our tour guides who was local, and I asked her, just out of interest, do you know anyone who has Alzheimer's or anyone who's been affected by it? And you know, I can ask that to this room, and there will be so many people. Almost everyone will know someone. Not in Cyprus. And that's anecdotal, but I think part of the reason is potentially that protective effect of the diet. Socializing is a good one, and it's great because it's fun. And exercise throughout the lifespan, protecting yourself against things like heart disease. Mental health issues are a big risk factor. Yeah, and then also things like losing your senses, particularly, actually if we go back to the Lancet, just the Lancet should be asked this question rather than Mirror. So things like vision loss later in life, excuse me, but also hearing loss midlife, so generally the loss of the senses, and also incidentally, delirium in older people, which is, my grandma had this fairly recently. Delirium in older people is a super big risk factor for, if people don't know what delirium is, it's when older people just start hallucinating and just be unsure of where they are, and it just comes on, and sometimes it can just go. My grandma was in hospital for 5 days, completely unaware of where she was, and then 5 days later later she was fine. But delirium increases your risk factor for elderly people. So yeah, there are a bunch of environmental things which have been linked to Alzheimer's.
How are these genetic tests like 23andMe predicting Parkinson's and Alzheimer's if it's not?
Sorry?
How are these genetic tests like 23andMe and a bunch of other companies who are claiming to do some genetic tests, how are they predicting this?
Yeah, so I don't know what 23andMe's thing is, but like, if they are to focus on anything, it will be that APOE4. So a few years ago, one of the 500 actors called Chris from the Marvel Cinematic Universe released a statement saying, "My doctors have told me that I'm super at risk for Alzheimer's disease, and now I'm going to go away and come up with a plan which probably involves a personal trainer and loads of money, right?" But I don't know for sure, but I suspect what he's been told is he has a particularly high expression of APOE4. Any other questions? Yeah.
Fantastic talk.
Thank you.
So, very good work. I have a question in regards to the synthetic data you're using. How are you validating it? Are you using any conditions to support the validation of the synthetic data?
Any conditions?
Clinical,
Yeah, so we're validating it by modeling. So what we're doing is we've got the original data. We create the VAE, the variational autoencoder. We then create the synthetic data. We then train the model on the synthetic data. We validate it on the real data, and then we test it on the real data in order to see whether it's able to produce. No, that's wrong. Train on the synthetic data, validate on the synthetic data, test on the real data.
And you are scared of any biases connections there? Because you're using one set of just the small things of original data
Yeah, biases are a concern, and what I will say is that all of the studies presented here need to be validated on a sufficiently large data source. So things like ADNI, cohort data in general is finite, extremely finite in fact. And so the validation, external validation, which I was able to do, not on the VAE study, but in the deterioration and the survival machine learning and deep learning studies, were able to be validated on external data set. And this is essential within clinical modeling in general. Good question, thanks.
Sorry, thank you for the very nice talk. I was wondering if you can tell me a little bit more about the data. So, for example, like, do you use data from just patients or also, let's say, healthy individuals? Because the goal is to predict an early onset of Alzheimer's or dementia.
Yeah.
And in that case, more like using patient data is like already biasing the model to diagnose or like future diagnosis, like how would the early detection work in that case?
Yeah, so this isn't patient data, technically, it's cohort data. So this is, all of the studies use, have at least three of these diagnoses, but one of them isn't a diagnosis, one of them is baseline, so that's cognitively normal. So they're recruited cognitively healthy and neuropathologically healthy participants as a baseline. So it's not just people who turned up at a hospital, it's people who have been actively recruited, even if they're healthy.
Hello, thank you so much for the talk. My question is kind of, I'm curious, let's say your algorithm predicts that this person is going to have dementia or AD, and your recommendation, is that also given by AI what to do? Is the recommendation still take medicine and do exercise? I mean, I'm trying to figure out the model once it's completed. Is it just to say you will get dementia, or will also provide some solutions?
So it definitely wouldn't provide recommendations because that should, I think, always remain with the clinician, right? And it's about what I used to call data-informed rather than data-driven modeling, right? So if you have one of the few medical AI models that is actually working within the NHS is down in King's College Hospital near Edgware Road, I think, where they have a AI model that detects images for breast cancer, right? So it says, oh, this person might have a shadow, or I don't really know how it works, but ultimately it sends that information to a radiologist, who then makes the final call. Okay, and so that in clinical applications, but also in a lot of other applications, that should always be the way it works, right? It's now called human in the loop rather than data informed, but that is particularly important within a clinical domain, because it's all about building confidence, right? We need people to have confidence in a model, and you can't get to a point, people are not going to trust a model who's just blindly assigning, you know, you have cancer, you have dementia, inshallah, off you go, you know? So that's the thing. So having that, the doctor in the loop will always be part of the plan. Alright?
Congratulations on the presentation. Every day we get this kind of academic level. Two quick questions. One is, have you tried for the time series any models like IMA, SALIMA, or algorithms which are, let's say, tuned for time series? And the second one, which is probably more one interest, you said that there are 45% could be prevented. Are there any, to your knowledge, any actionable things which we can do, or people can do, not only, you know, eat vegetarian, probably something which is actionable, people can do in order to prevent?
Yeah. So to the first point, I don't think that mic is working, by the way. So to the first point, so technically speaking, this isn't time series data, right? So what it is we have people coming in at discrete points within, and so therefore it is irregular, right? So this participant may come in 7 times, this participant may come in 3 times, and then they'll all stop at different times. So we focus on models which use discrete modeling using cost proportional hazard model. And something else to say is that the cost proportional hazard model is super familiar to clinicians as well. And so therefore that helps with the idea of building confidence because clinicians understand it. Now to your second question, so there have been a number of studies, the Apple study, there's one coming out of Finland. The Apple study is ongoing, by the way. It's at UCL, I think, where they assign people they identify people who are at risk, they assign them a sort of live tutor, where they essentially say, why don't you start engaging with exercises, why don't you start doing crossword puzzles, why don't you start doing engaging a bit more with your friends, and that type of thing, and that has been shown to have a marked impact, even at a late stage where someone has been identified at age 60 plus, for example. So there are actionable things that we can do. We just need to, because it's all very well telling everyone just to say, oh, exercise more and have a better life. You know, the government's been trying to do that for decades, and I do not have a very healthy life. I do a PhD, so I go to the territory, but like, I have a full-time job, so we need to target it better. We can target it, and there are actionable things that we can do.
I have a question about the large language model. I understand the machine learning bit, but why would you use a large language model to explain what? The last step, you have a model, right? A couple of steps. Some analysis, machine learning, all sorts of other things. Then the last step is large language model transformer.
Yeah.
To do what specifically?
So essentially, ultimately, it's trying to improve prediction of risk across time. And the insight that came from the paper that the actual model that I modified was from Lee et al. Coming out of Cambridge, the AI for medicine department. So ultimately, it's about improving the accuracy of risk across time. So it's not so much a large language model as it is, we've taken the architecture underpinning a large language model, we've modified it, and then we've said, hey, rows of data across time, kind of like a sentence. We can work with that. So that's why we ended up doing it. But the question becomes, if we get it to the point where we're super accurate across time, we're able to mold this timeline of risk, but we can't really explain how we're doing it because a transformer is so black boxy. We don't really understand how it reaches its decisions. What can we do? Well, one thing we can do is we can just focus on things like survival around the forest, which has predictor importance, that explainability inbuilt into it. But what if survival around the forest is not good enough? Then we go into explainable AI and trying to decode what's going on under the hood in the transformer model.
Okay, thank you.
Anyone else?
Thank you, Henry, for
Nice.
that. I think fantastic. That's in the intersection of biology, prediction, predictive AI, and many ethics as well. I think AI is now pushing the foundation for, I think, safer, earlier, and maybe humane care in relation to Alzheimer's. So, thanks a lot. Now, we'll take about 15-20 minutes break, and then of course, we'll be convening again for the next session. We have Damian ready with his talk as well. This is about analyzing UK's energy development and preventing NIMBYism, I believe. And Damian has been working with Adamod, but this is a project that he has built on the side, especially addressing not in my backyard kind of energy development projects in the UK. And I think he has also got an interesting demo as well to showcase, especially with MCPs and agent to agent. That's an exciting topic because I also work in the agentic AI space. Yeah, so with no further ado, Damian, no, please welcome.
Just want to say, great first talk. It was really clever. This is the complete opposite of that. I'm a very dumb person and I made a very dumb app and I hope you enjoy it. It's called the NIMBY Dex and it helps use AI agents to analyze different terrible information about British energy fears. About me. I'm an AI software engineer and creative technologist, so I work a lot with a bunch of different artists in creating weird technology projects, and also had a master's in computer science, 4 years software development. I've worked in a lot of different fields, leading data science for some large-scale industrial decarbonisation projects across the UK, a bunch of different AI startups ranging from creating weird AR glasses to wind energy predictive modeling. I currently work in my main role as a AI software engineer within nuclear consultancy, but essentially I've worked on a bunch of weird little projects and now I want to make my own. And what I'll get through within this talk, hopefully, a lightweight explanation of agents and model context protocol. So who's aware of model context protocol? Lovely. So we've got some hands up, so feel free to correct me as soon as I say it completely wrong. We'll talk about the NIMBY Dex and the problem of NIMBYs within the UK and how we might be able to quantify that. We'll do a little infrastructure walkthrough for how the app was made and how it was made quite quickly and maintainably, with some tiny code snippets, some results, why I decided to use Model Context Protocol in the latest version, and a list of terrible and hopefully funny planning failures. And then I'll walk through a bit of the future of energy planning and how we might be able to optimize it a bit further. So firstly, LLMs, agents, RAGs, and MCPs. So if you're not aware, large language models are language models trained on the internet and loads of pirated books, as we're finding out. An agent is a way to give those LLMs access to tools, memory, and planning, and start charging 70 quid a month. And then retrieval augmented generation, you give a large language model access to query different parts of memory, usually with a vector database, so that it doesn't tell you to eat rocks, as Google famously did. And Model Context Protocol essentially is a way to standardize the way LLMs access different tools and applications. So when they blow up the world, it will be standardized and a protocol. So what's a NIMBY? Not in my backyard. Essentially, it's a organized practice. I think it was initially coined in the US, but it's all about opposing new developments in your area, whether it's a wind farm, whether it's new housing, whether it's any kind of clean energy. There's a lot of people that do not want wind turbines near their houses, and it's usually organized primarily very, very close to someone's area. It's a very common theme in the lack of development within the UK, at least when you look at things like social media or when you look at things like news stories. It's a constant thing that people keep saying about, oh, NIMBYs are the problem, NIMBYs are the problem. And I kind of wanted to tackle, well, are they actually, or is it a really, really easy way to put blame on someone for a bunch of different issues with energy planning? So why? Essentially, there's a couple of statistics that have come out. People think that NIMBYism in Britain raises the cost of wind power from 10 to 29%. 80% of projects in the EU are currently stuck in the permission process. It's hard to differentiate whether they're valid reasons, like stuff like what we've seen in Spain with the grid not being able to take certain pieces of renewable energy, or whether it's people being really, really silly about clean energy in their own backyard. And mostly I've done an entire year of silly side projects, and this is one of them, and I hope you enjoy it. So the foundational data, it's gorgeous. It's this massive government data set that's updated every 3 months or so. It contains every single renewable project since the 90s. It basically is really badly made. The fields are randomly filled in as someone decides to. Projects are really hard to track and find. You can't really analyze anything about it because they're all related to specific other council databases that don't have links associated or have timed out since then. So it's hard for even a human who knows what they're doing to work out what the project might be. And yes, essentially every project here has a related database of a specific council that has been made, again, in the 90s and not updated since then. So initially I created NIMBY version 1, which was very silly, and it's not Nintendo related, so please don't sue me. It was a tracker for cancelled renewable projects. The front end was made via MapLibra and Svelte, which made it really kind of performance intensive, but works really well for large data sets. There was an AI-powered analysis, essentially using a custom Gemini agent with Python, quantified some renewable projects in a non-boring way, and included a bunch of snarky commentary. So I'll show you the current version. And it's a nice little map. Oh, that's bright, sorry. And essentially what it does is shows you the capacity loss due to cancelled renewable projects, the amount of projects that have been cancelled, an average delay before death. So you'll notice that since application date, this year has been the only one where the average delay is less than a year. So you put planning permission for a project and then find out a year later, after putting a bunch of effort, money and time, that actually you can't build that solar farm there because there's too many mice, which is one of the projects that I've seen. But essentially it lets you view the different projects around the area. All of them have been cancelled at a certain date. The great thing with MapLibra is that you can get quite good performance intensive scrolling and nice reactive components. So you can go to a specific location. It will give you a little analysis of how NIMBY it thinks it is. A lot of it's based on a mixture of news stories about the location and the actual planning authority database. You can copy a reference, and if you're a psychopath, you can go to the specific council website, view that application, and see all of the 500 documents related to it. Would I recommend it? Yes, it's very fun. You can essentially view how much a single solar farm requires, which is normally about 50 or so documents of different distribution dates. This is really difficult information to try and get without this NIMBY Dex. Because you have to know the reference ID of a certain site, you have to mix it together, and then you have to also know that it's, oh no, I've downloaded it. I've downloaded the heritage statement. That's great. Thank you, Chickwell Weymouth. But this allows me to analyze a bit further and work out whether a project has been cancelled for a good or a bad state. This is all online as well. The link will be at the end. Hopefully I've not deleted it. But that's NIMBY Dex as a mini fun demo. And the tech stack for the version 1 was really quite simple. Essentially, you've got a RepD dataset, you've got human processing for certain other fields, goes into a Python pre-processing backend. Some GeoJSON is created from these areas based on their location. Same with analyzing it to a specific council. I can get the kind of boundaries and relate it. Then Google Search API integration alongside Gemini API. So it basically gives Gemini a prompt for searching for a specific site based on all the metadata that exists for it. That site is then passed and put back into another AI agent that then analyzes it, tells you a silly little quote from the news story or from the site, then proceeds to put it on the front end of the map. It's deployed in Vercel, which is, again, really, really quick deployment speeds. Markdown as well performs conversion for pretty much anything. So you can give it like a large PDF, large HTML with a certain limitation, and it can pre-process them really well. Then the front end includes a lot of Charge.js, MapLibra, like I said before, and Vitensfeld. Vercel destroyed my wallet for a single day, but that's okay. So thoughts on Gemini. I did this talk for the first time 8 months ago on a first early release. It became outdated within a month. Then it no longer became outdated. Now it's outdated again. So I keep it for when it becomes in date for the next time. Gemini is currently the best of the large language model litter. It's got a really generous free tier. If you've ever used either Firebase, Gemini Studio, or their newest AI Studio, it's insane at what they give you for free. Essentially, you can pass an entire subset of UK energy generation, which is not an insignificant amount. And Gemini lets you test some naive data with Search API. So it gives you a really good early validation for whether a project is feasible or not. And really, really simple model context protocol and agent generation as well. So the app became quite good at identifying legitimate versus frivolous concerns. So it managed to analyze whether, for example, a solar site was being built with absolutely zero knowledge about the nearby residents versus someone being really upset about hedgerows. Alan Titchmarsh kept appearing. He hates solar near his house. He's been involved in multiple different projects, specifically talking about reducing renewable energy and reducing kind of projects that get applied nearby. There was a solar farm near a landfill. There's a really good quote from a genuine councillor, which is, "We've got hot rocks 5 kilometers hot and the hot rocks can produce electricity," which is a direct quote. This person got elected into office. So again, lots of quite funny examples from people being really, really silly about developments happening near their houses. It's not perfect, and it hasn't been perfect for a lot of different locations. It really, really got into referring to people as meat bags at any given moment. I didn't teach it to do it. It just decided that it hates people after a certain point. Hates ancient woodland as well. No matter what, if something's being built on ancient woodland, it will say, "I don't care about ancient woodland." Roundabouts, won't someone think of the roundabouts? That came after a incorrect hit, which was a massive PDF document about roundabout design within a specific council. And solar farm near Maggots End, I hope the residents aren't afraid of sunshine. Essentially, model context protocol, the setup for the V1 version was quite simple, quickly became crazy. Often you can get a way better source of truth for a specific renewable document. It's ambiguous as to what the better article is, so you can't just analyze it via classical means. Some sources need to use different tools depending on different model structure. There's essentially 5 different versions of council PDFs that are regular, and there was a lot of wasted repeated searches when something wasn't a better result. So model context protocol essentially firstly allowed me a nicer way of interacting with this weird, badly structured data. It was a lot cleaner for some of the development. So what it meant was I can assign different tasks and roles and have that be within a actual nicer protocol. And finally, I want to see how hard it would be to integrate it. It's quite novel. I think it came out within the last 6 months or so, at least became popular in the last 6 months or so. And I want to see how hard it is to integrate into a pre-existing system. So is it hard? Here's a small example, which is a silly little fast API route. And all it does is performs processing of a certain document. There's a bunch more info within it, which gives you the kind of MIME type for a document, some additional data. But converting this to use model context protocol so that an agent can use it is really, really simple. Firstly, you import fastMCP, which is a popular Python library. You mount it into a specific server, and then all you do is change it to mcp.tool. You can essentially then create a MCP server from about 5 lines of code, which makes it really, really easy. Then on the client side, it's even simpler. For a model like Gemini, they've got server tools accessible. So as long as you've got a separate client and server config, You can use whatever model is popular. The majority of APIs now either can work with something like MCP or support it. So it's, again, really, really easy to integrate with a normal tool, which led to this refactor and this massive V2 stack, which integrates a couple of different things. So firstly, you've got the normal setup for the NIMBY analyzer, but then there's a nice development environment tool. So essentially, if I see a certain article or something that doesn't look correct, I can call an MCP tool, which will then work out what this is, try and find it with updated site embedding logic, and it provides a neater way to update these random council pages. So one of the things that I've been integrating is a way to look at specific council documents and then update a certain site with additional information. And this does it a lot cleaner than me putting in, 1,000 lines of code to do it. So what the hell did I learn? It's not NIMBYs. There's a massive problem with British planning. They're really easy to blame, but every single time you look at a document on NIMBY, what you end up seeing is massive council websites, about 50 different pages of PDF documents. I was just looking at one this morning, which was 3 different PDF documents for trimming hedgerows around a solar farm, which involved, I assume, tens of thousands of pounds of different people analysing it. One of the attitudes within that document was saying that if a single mouse is spotted, this entire project needs to pause, which I think shows the amount of risk for someone trying to develop renewable energy in the UK. You can buy a site, spend a bunch of money, and then just have it denied because the hedgerows aren't trimmed well enough. Here's an amazing example, which is Forside Community Wind Farm, quite massive infrastructure project, 315 megawatts, 45 different turbines. How long do you think this took to refuse? Any takers? Any? 4.5 years. So from the first planning document to the end appeal being cancelled, finally by, I think, an MP this time, this entire document, and I think that LinkedIn article, that QR code right there links you to a little post about it, which describes some of the different documents that are within it. 496 different documents, 111 public representations, and 285 application documents, which is absolutely insane. All of those are about 20-page or at minimum PDFs or massive restructuring happening. So yes, it's a big problem. Future improvements, there's a lot more that I want to do to make the app a bit more fun. I want to add a way to submit corrections to get a little NIMBY trainer badge, but at that point I may get sued by Nintendo, as well as adding some options for essentially being able to counter-organize local support against some of these ongoing complaints. Because what tends to happen is you've got a project that's ongoing, a group of people will submit about 20 complaints saying, no, I don't want this near me. Actually, people that don't care or do want it near them never really get the opportunity to submit anything, so there's not really any choice they have in the matter. Alan Titchmarsh should be a legendary NIMBY mon, which will definitely get me sued. And then a small breakthrough. So while I was working on some of the council websites, I tried integrating an initial MCP tooling, and actually I found it really, really easy for the model to be able to navigate these massive pages and pages of PDF documents via something like MCP. And really the entire goal of this is to have humans spend more time reading obscure government documents. So hopefully If you enjoy this talk, you'll spend some time reading 20 different pages of cancellations. So thank you very much for listening. It cost me £5.70 overall. Thank you.
Any questions?
Can I ask a question? For those successful projects, their characteristics are different. What I mean by that is, do they look, in terms of the number of documents, the length that it would take to get them approved? Is there any difference?
So I've begun some analysis of this, and I know some people in the sector, and in terms of amounts of documents, no. So typically this kind of planning is the same for cancelled projects as well as successful ones. Obviously there's some outliers here and there. Essentially a lot of the problem comes from the amount of effort that you need to put into these documents means that it's very, very large suppliers that know how to navigate this space that do them, which limits a lot of the capability for, you're not gonna, if you got 100K tomorrow, there is no way you'll ever start a renewables project because there is so much legal aspects, so many different organizations that you need to speak to, which makes it incredibly difficult. So the typical pattern with a lot of the successful projects is they're part of a larger organization, whether it's an organization that's got a bunch of projects in the EU, and it's essentially those suppliers that end up getting a lot of different wind farms and a lot of different solar farms and a lot of different organization.
What actually gets you to this project? It's very niche.
Yeah, it is very niche. If I'm being honest, I'm not sure. I think I read a single post from someone that was talking about how, NIMBYs are the sole root of problems in the UK, and I thought, is that true? And then I got down a rabbit hole, and then it's 8 months later, and I'm making a massive map of the UK. So actually, just the, yeah, it's a good question. I'm not sure why I made it.
Tell us how you validate and what the MCP was doing, and how do you check if it was accurate?
Yeah, so that's a really good question. It was something that I encountered initially in the V1 version. So what you'd have is approximately a 40% hit rate for single search API calls. There was some improvement from being able to do 5 or more API calls to Google search and then picking the best one via another agent. But some cancellations don't get news articles written about them. I think the main aspect is searching for the ground source of truth within this. So, for example, this is where the council sites come in, where I can get actual documentation and actual objections from a specific site cancellations. That lets me validate that a specific thing has been cancelled due to a lot of objections or due to really, really valid reasons. The NIMBY level is completely subjective. It's basically what the model wants to spit out at that any one moment. I don't think there is an objective measure for being able to tell whether a project has been cancelled by NIMBYs because there's this massive swathe of documentation. So the best I can do is go, there's a bunch of really, really silly objections that have happened at the same moment as it being cancelled. And there's an MP that really, really hates renewables. This is probably an NIMBY project. But in the end, it's all subjective and slightly silly.
Thank you. It's a very, very good presentation.
Yeah, so my name is Waizen Odegwa, and I'm a full stack engineer at a company called Calico. We're in the AI and simulation space, plus modeling as well. And yeah, I have lots of experience with startups, founding engineer, building B2B apps, B2C, SaaS platforms, and all that. And yeah, my spare time, I do open source work as well. There's a popular data processing library called Down4JS. Has about I think about 5,000 stars. And if you've used pandas in Python, it's basically the JavaScript equivalent of pandas. Yeah, I do lots of AI projects day to day, and also on my personal free time. My latest project is called ByteMind, and I think I linked it. So it's basically an AI-powered app to learn anything. So it uses AI agents in the background and turn your idea or your curiosity, any topic, into structured content. Yeah, and then what else? Oh, I just closed it. So give me a minute. I totally forgot that was a browser. Just a minute. Okay. All right. Sorry about that. And yeah, you can connect with me, GitHub, LinkedIn, on my website as well. So yeah, what am I talking about today is lightning talk, so I'm gonna try and be fast. It's basically a smart calendar that you can chat with. So I'm gonna show a quick demo. I tried to do the demo on my phone when I came in here, but I could not get the dev view to start up because it's on a different Wi-Fi. So I have this pre-recorded video just to show you briefly what you can do with the app. So yeah, what it does is that briefly it connects all your calendars. So you can have Google Calendar, Apple Calendar, Outlook. Those are the three calendars are integrated. And you can basically chat to it. So you can talk about your schedule in natural language. You can use it to create events, update events, delete events, basically manage your entire schedule all with text. So you can see I'm asking questions. And in this demo as well, I did an update, but it's kind of fades that. And then I added a please at the end, and it's actually tried to do the update. So yeah, has like a confirmation modal because you're doing something a little bit risky. So it kind of like confirms with you, is this the event you want to update, or is this the event you want to delete? And you can kind of like confirm that. And then I think the last thing I did there was to do a delete. Yeah. Quick deleting of events. It searches all your calendar. So if you have more than one event with a particular keyword, it can pull out all the events and ask you to pick the one you want to do. So yeah, basically that's. And if I go back here, I kind of like tried to list out the problem, why I decided to build this. But to be fair, I actually decided to build this because I saw a tweet from someone that said, oh, what I would give if I can chat with my calendar. I was like, oh, that's actually a cool idea. And I was like, I wanted to do some stuff on agentic AI and kind of doing some RAG with real world data. So I was like, okay, let me try out this project. So that was how I started building this. So the problem is that we have multiple calendars. So if I want to check my schedule today, I go to Google Calendar, check my work schedule. Sometimes I have Apple Calendar events and all that. I go to different places to check my schedule. They are all siloed, context switching, poor discoverability. I found out that at the moment, we have Apple Intelligence in our phone, but I tried to chat with it to get my schedule. It failed, and it's 2025. You'll be surprised. Apple should have done or fixed this at this time, but it's still really bad. You can't talk to your calendar at the moment. So stuff like when did I meet Sarah last about Project X should just be able to pull up the details from your calendars. And then there's delimited intelligence. Calendars are static, not conversational. So the vision was like, why should I not be able to do this? I should be able to just say, we're scheduling my 2 p.m. meeting for next Tuesday, and it goes and do that for me. Can I have a donut with somebody this morning? Checks all my schedule, and just tell me, no, you have an event, or yes, you have 2 hours of free time. Just tell me. So I should be able to do this in July 2025 with all the technology that we have. I should be able to do this. So yeah, that was just the goal. And so how was this solved? Well, first you have to get data. So multi-source sync, Google Calendar, Apple Calendar, and Outlook. So Google Calendar and Outlook have an API that you can connect to, so you can pull data, you can pull calendar events. And iCal, which is Apple Calendar, you can, if you're on an iOS, you can basically sync the local events directly. So that's what I did. And then you can chat with it in plain English. I connected that to OpenAI LLM. And then another thing I did also was you can do semantic search. So you can search by context and not just keywords. I'll talk about how I did that briefly. And then scheduling, when you say, okay, I want to go for coffee tomorrow, it will automatically search your events and tell you, oh, you have a conflict. There's already an event there. Do you prefer this time? So you can do smart conflict detection. So what is the tech stack? Quite straightforward, because I wanted it to be a mobile app and I don't want to write native code. I use React Native, so you can deploy to both iOS and Android from one code base and even web as well. And I use Expo to manage the entire build process and everything. Backend was Superbase, powered by Superbase, so everything from auth to database to vector embeddings, which you'll see in the architecture, to edge functions, all came from Superbase. And then I used OpenAI for the LLM, and I think I later switched to Gemini, because as the last speaker said, it was really cheap. So I actually switched to Gemini. And the architecture is an agent-based processing pipeline, so multiple agents doing different things. And then the data came from Google Calendar, Apple Calendar, and Outlook. And this is the quite straightforward and simple architecture. So you have the native app. It requires local or OAuth access. So for Google Calendar and Microsoft, it requires OAuth access. So you basically have to log in with your details and give me permission to access your data, your events in your calendar. And then for Apple events, I use a library called React Native Calendar. It pulls the calendar events locally from the device. So we put all these from the different sources, and I did like a normalization. So they were kind of like structured differently. So I normalized that into a single structure and saved them in a Superbase table. And then as soon as they're saved, there was a database trigger that automatically takes each event and embeds it. So we embed that so that they can be searchable later, so that I can say, do I have any swimming events? And it can take swimming and match that to like relevant events based on context and not just keywords. Because if you go to Apple Calendar today and you search for swimming, it's going to try matching by exact keyword, which is sometimes not useful. So as soon as the calendar events are saved, a database trigger runs, and then we embed that and save that as embeddings in another table. And then from the app, if the user sends a query, like for example, what do I have tomorrow? We take the user query plus their current time zone, send that to an edge function, which is like a chat handler. It sends that to a query analysis agent that analyzes the query and kind of like wants to know what the user wants. Is the user asking for information? Are they trying to update? Are they trying to delete? So it has to know the intent of the user. So it analyzes the query to find that intent. As soon as it gets that intent, it passes it over to the calendar data agent. This takes that intent and pulls the relevant information. So for example, if the user is searching for something, it runs a search. If they want a specific date event, it pulls that specific date. If they want to do a mutation, for example, they want to update, it knows and calls the relevant function to do that. And then it takes all that information and passes it to a response generation agent, which basically just summarizes and formats the answer correctly and sends back to the app. So yeah, so that's the architecture. And then, yeah, some of the components which I talked about, multi-source calendar sync, better embedding for search, agent-based processing, and real-time updates as well. And this is the normalized table. So when we pull the data, calendar data from the different sources, normalize them into a single calendar event. And this is just an example of the event embedding table. So you can see it is keyed by the event ID. So we can search them. And I use Superbase GT small model to do the embedding because it's quite free and cheap. So you can switch that out for maybe OpenAI embedding or something if you want more powerful machine. And yeah, so this is the most important part of this entire project, which is the agent-based architecture. And this was kind of more of like a learning for me because another reason why I actually wanted to build this was that I wanted to build custom agents without using any library, because there are lots of popular library, ADK, AutoGen, and the LangChain as well. But I wanted to build this myself and see how agents actually work. So yeah, so it's a multi-agent architecture, meaning you have multiple agents talking to each other. And I broke it down into 4 agents. The one that analyzes the query to get the intent, that is literally the first point of contact. So once the user sends a query, it goes to the query analysis agent, and it breaks the query into 3 different operations or query type. There's a keyword search. So if I'm trying to search for something, do I have any swimming event? I'm trying to search for something. So you say, okay, that's a keyword search. Send that to the calendar data agent. Tell it to do a vector search and find all the relevant events that relates to swimming. Take those relevant events that relates to swimming, plus the user query, and send it to the response generation agent. So the response generation agent takes all the events, takes the user query, and be like, okay, you want something related to swimming. These are all the source of data I have. I can summarize and give you a response. If it's a date-specific agent, for example, if I say, keyword, query type, for example, I say, do I have any event tomorrow? Tomorrow is date-specific, so I can just go to my database, get all the events for tomorrow, pass that alongside with the question to the agent, and it can formulate a response. And then for event operation, if I want to delete or I want to update, that's basically an event operation. I want to do something, I want to perform an action. It sends that to this agent. So if I want to delete, it means I want to delete something. So it has to go find that event. So if I say I want to delete the dancing event I have tomorrow, it's going to combine those stuff, get the relevant event that I want to delete, and pass that to the response agent. So that's basically the breakdown of it. And for all this, I just created a simple, kind of like a TypeScript-based pipeline where you can add agents in different steps, because most of these agents, they either run in parallel, or they run sequentially, or they run in a loop, or they are conditional, kind of like 4 different types. So this architecture, yes, is that query analysis agent sits in front of it, passes to either calendar data agent or event intent agent based on a condition. So there's a condition in here, and then the next step is the response agent. So if you notice what I did in the pipeline here, I first added the query analysis agent, and then there's like a conditional agent here that says, okay, if the query type is event operation, you call this agent, else just move on to the next one, which is the calendar data agent. So kind of like a simple pipeline. And if you've used agent tools, this is really familiar, because you kind of like build your agent in different steps like that. And then you execute it with a state. So it has like an initial state, which for this example I just used like a simple object for that, which all the agents can write to. You can write to that state. Yeah, definitely not production ready, but for understanding it works. And then, yeah, this is like an example of the query analysis agent. It extends a simple base agent. The base agent just takes a prompt, a system prompt, and calls an LLM. That's just what it does. It's very simple. It takes a system prompt, calls an LLM, return the results. So it just extends that. So this is the system prompt for this agent, and it just calls this LLM with that system prompt. it gets the answer, and you can see it mutates the state and sends back the response. Yeah, so that's an example of the query analysis agent. These other ones do the same thing. And then there's like the agent flow, which I think is familiar already. Starts, goes to this. This is an event operation, goes to this agent, this date specific, goes like that. You get the response, and you go to the end. Just going to move quickly. And so some example, what's on my schedule today? Today, date specific. I don't need to go search. So I just need to get the current day and just pull those events. Do I have meetings about product launch? Keyword search, you need to search something related to product launch. So that's a vector search. So it's going to pull all the events that are talking about product launch and use that to answer. Cancel my 2 p.m. meeting tomorrow, that's an operation. I want to do something. So I want to delete an event. So the query type is event operation, so it maps it to the correct agent. Same with all these as well. And this is just an example of the shared state between an agent. So you can see it's just an object, key value store. And all the agents can write to that particular object. And once we have a response, we know that this is the final response, and we'll send that back to the user. I just added some of this here. And there was also an issue with syncing the calendar. So for example, what happens if I added a new event after normalizing all my data at the beginning? So the user comes to the app, sync all their data, and they start asking questions. So what happens if I add a new event outside the app to my Apple calendar? Well, I don't have time. Okay. So yeah, so basically how to fix that, did the background sync, and from time to time, it automatically pulls the fresh data, re-embeds it, and updates the vector embedding. Yeah, so that's it. I think I learned some lessons on this, some things around vector search nuances, generic model needs domain tuning, hybrid search, so it's good to combine vector and traditional search. That's important to know. APIs are inconsistent. Apple Calendar does not support real-time updates. I just found out from building that. Time zone hell is real. I mean, lots of people understand this. And then user experience, speed is important. Try to stream in response. If you're building LLM apps for users, try to stream in the response to the user instead of having them wait to get the entire response back. And then show sources. So if you notice, I showed like the event source that the information was gotten from. So this is very good to earn trust. Yeah, and that's it from me.
Fantastic, that's great stuff, I think. Any questions on this?
Thanks. That looked like a really interesting project, especially the fact that you built out all the component parts and really explained it like very well and transparently. Building it up from scratch, very insightful. The naming that you use, how do you decide? Because I find I get confused with how people refer to multi-agent systems, because typically when I see like agentic workflows,
yeah,
each step gets referred to as an agent, and it confuses me.
Yeah.
Because I guess it's because I've got like the whole building effects of agents, but in time, agents is like agentic loops, we have an agentic abstraction there. So yeah, curious how you're thinking about naming what you kind of came across as a
Yeah. Yeah, I think I kind of like break them down into what they do, what they specialize in. So if I'm trying to work on a task, for example, this task, I didn't start by just breaking it down into query analysis agents, event intent agent, and all that. No, I started by using one agent. So I had just one big, massive prompt, system prompt, and that prompt says, if you get this query from the user, try to, first of all, get the intent. If you get that intent, send it back, call a function, because you can do function calling. Call a function that finds the data. Once you get that data back, use it to answer the question. But I found out that because there were like lots of functions that the agent needs to know about, there are lots of steps, and that one massive prompt was getting so big because I kept adding lots of things to it, and sometimes it's mistakes, event intent for calendar requests and all that. I decided to say, okay, let me break this down into specialized agents. So for example, one just does query analysis. So it's very good at that. Just analyze the query, return the response. And one just does calendar data. One is just calendar data specific. Just your job is to fetch the right data. So I think you kind of need to just break the tasks into specializations, different areas. So if you're doing like deep research, for instance, you can have parallel agents that search different domain. So you can say, okay, your job is to use Google Search API, search these specific areas of the internet. Your job is to use DuckDuckGo API, search this specific part, and then you combine the results together into one. So yeah, you can use single agents, but it becomes really unmaintainable quickly, especially when you're doing like kind of like complex tasks that involves different areas. So I don't know if that answers your question.
Mainly about the naming, but
Oh, the naming, yeah, this is just me just speaking that. So it's like how you name your functions in code.
each thing is called an agent as opposed to like a node.
Yeah,
Whereas I think for an agent, like something like deep research,
yeah,
is a standalone agent that's fully autonomous.
yeah.
Is its own agent within the system.
Yes. So basically, the agent, when we say agent, is just an LLM that has tools. So ChatGPT with tools is like an agent. So if I can be the search agent and I give it a tool, the tool is just Google Search tool. So you can, once you give it a question, it calls Google Search tool and use that to answer your question. So that's an agent. If I can have a flight agent that has a flight API too. So once you're searching for flights and you ask it a question, it uses that too. So I think the agent is just like an umbrella term for like an LLM that has access to tools. Yeah.
Cool. Anyone please?
Yeah, just a quick up from me. You mentioned when the data is coming from the outside, that could be a bit of a problem to obviously have to put it into the database. And you mentioned periodically plotting the calendars. Are there anything like webhooks that would automatically send any updates to the calendars from the outside you could use to basically have an event-based response so you never get out of sync with it?
Yes.
Unless I missed something.
Yes, the question is, I think, so for Google Calendar and Outlook, they have webhook APIs. So the only one that didn't have it is Apple Calendar. So I had to combine both. So I did a bit of webhook for that, and for Apple Calendar, I periodically did like a background refresh for that. So yeah, just combine both, yeah.
Thank you.
Right.
Nice presentation. I wanted to ask about like more of like the Philium process you encountered, because like it can go through different processes with different decisions. Eval is just what we're talking about in time, but like what was your core Philium roots? Like, are you experienced wiring agents?
So I didn't do eval. I just did like back and forth fine-tuning of the system prompt. So, but I think the major part that was an issue was actually the intent, the event intent. So for example, if I wanted to delete or update, that was like the major part. And also I think there was an issue with my embedding as well. So it was very, how will I put it? It was okayish, but most of the time, if I say I want to delete a particular event, it returns something that is unrelated. So I think to solve that, probably just use a bigger embedding model. So I used a very small one just to save cost. So yeah, so that was another issue. And if you don't provide the right data, the LLM basically fails. So I think the core of this application is actually providing the right data. So the search part is the main bit of this information. The LLM part is quite easy because just give the LLM the right data and give it the question. It can answer your question correctly. The important part is getting the right data, number one, and also being able to embed it correctly. So it can kind of like pull data for vague user query. So if I say product launch, you should be able to get all the specific events that are talking about product launch. So yeah, so that was the core issue.
Last question for the day.
That was quite an interesting talk, quite related to what we do at the moment. It's amazing. It's quite interesting to mention the kind of issues you had with embedding.
Yep.
We have similar issues with flat data sets.
Flat. It's a flat data set.
We have different, similar issues with embedding.
Yeah.
What we then decided to do was we then introduced the concept of a vector database.
Okay.
After the embedding, and we use things like LangChain and LangFlow, basically. So the LLM, it interprets the LLM and gives you the wider context.
Yep. Yep. Yep.
Thank you.
No worries. Yeah, I think I did something similar as well. So the embedding I did here was put in a database, and we also did like a vector session. But I didn't talk about that part. But yeah, but you definitely do a vector session. So, but the problem was just that the embedding model was too small because a very cheap one. So it was too small. So it was not really as good. But yeah, it can be solved by using a bigger one, but just have to pay more for it. Yeah, this was like a test project. So, and also you can fine tune an embedding model. So you can fine tune the model on calendar data. Yeah. Thank you.
Fantastic. Thank you, Rising, for helping us down the bar. I think that was great talk. I think we've covered a lot of breadth from medical devices to immunists to productivity tools.
Hi. Oh yeah, I need to give him back.
So now we have folks from SIGO who would want to announce their the upcoming event here. So
Have you applied to speak? Have you applied to speak yet?
Yes.
Who's the next one? The next one.
No.
Have they accepted?
No, I want to talk on my formal verification. Confuse myself.
Let me give it to you. There's a mic here.
So, as per our upcoming events, we have our AI Signal Spotlight event coming up on the 7th of August. And the AI Signals 25 is going to come on September the 16th. So please look at our website to get the details on the talks. Something as exciting and interesting as well. So we have Kunal for you.
Hello, I'm Kunal, I'm the field CTO at SIGO. Thanks for coming. Quickly, we host our tech conference. It's a community conference every year. We do it in the US, Europe. This time we're doing it in London again. We've had some nice speakers in the past. We had Steve Wozniak this year in Austin, Texas. San Francisco and Austin, Texas as well. This is a QR code for a launch party that we're doing. It's a 1,000-person event. The main tech conference in September. This one's like free to attend, so you have a lot of AI folks who are founders. It's a great networking opportunity. Again, this one's like free. It's a launch party for our event, so we'll be sharing some like discount codes for the conference at the party as well. But either way, if you can't make it to the conference, you come here. It's at the same location, so just wanted to share that. But yeah, and the main conference is called SIGO Navigate. So if you search online, you'll find it. Thank you.
Cool. I think the link might not be working for some people, but what we can do is share it in the AI Signals group afterwards.
You can also like search for SIGO on Luma, and there's just one active event you'll find there. So Luma is an event app. You can do that later as well.
Cool. All right. That's fantastic. Thank you so much, Kunal, for everything. And I think that's a wrap for today. The after party is going to continue in Angel Pub, and I think we have the Yeah, so if you could Google it, I'm sorry I couldn't get the slides up. If you could Google for Angel Pub, I think bulk of us will be heading there. So all those who have missed out alcohol and had your zero alcohol drinks, you can go, drink to your full. So thank you for coming over for AI Signals 24. Have a wonderful rest of your evening, and hope to see you soon on future events. Thank you.